Number 36 here is following the same set of directions as number 30, which I just did. They've given you a function here, an a value, and they want you to find f prime of a, and then they also want you to use that to come up with the equation of the tangent line to f of x at a. So let's get working here, guys. Let's work on equation of the slope of the tangent first. So our general derivative, f prime of x, is going to be a limit now as h approaches 0 of, and I'll skip the formula writing here, guys, f of x plus h. Now this gets interesting almost right off the bat. So all of the x's, of which there are 2, they're going to be replaced by an x plus h. So the first x is just going to be an x plus h. And then we have an x to the negative first power. I think I am going to rewrite that as plus a 1 over and then an x plus h underneath that. Am I going to regret that? Let's run with that and see what we see. I might change my mind in a minute. All of that is the f of x plus h, and then minus the original function here, which was, probably a set of brackets is a good idea here, x plus a 1 over x. And that's what our numerator here would look like, and it's all over h. So that's the formula as it applies here, and I'm kind of thinking out loud, if you can't tell here, wondering if rewriting the x to the negative first as a fraction here was the way to go or not. And I think it probably was, but this gets a little bit interesting here. Okay, this is where we're at, and I think we're going to have to do some kind of difficult work right here to clean up that numerator and hopefully eventually get a factor of h on the top that will cancel with that factor of h in the bottom. Now, the one thing I'm going to do to make my life just a little bit easier right off the bat, I guess this isn't earth-shattering, I'm going to just get rid of the parentheses here on the x plus h, plus the 1 over x plus h, and I'm going to go ahead and distribute this negative inside, and that's at least going to do one nice thing for me. Minus x minus 1 over x all over h. Well, the thing I see right away is that this x and this x are just going to cancel each other out, and that's what we're going to be left with on top. And now at this point, this is what I was, hoping wasn't going to be necessary, but I think it is. I think that we are going to have to combine those 3 terms up there in the numerator. And to do that, I think we're going to need a common denominator here, and I'm not sure if this is something you guys remember how to do from back in the day, but your least common denominator, or lowest common denominator, in the numerator is just going to be this denominator here, which is x plus h, multiplied by this denominator, which is another x. Now, there's no denominator here underneath the h, so I don't have to worry about that one as well. So what I have in green right there is the LCD that we need to work towards. Now, how are we going to do that? Let me kind of work backwards. This factor here at the end, the 1 over x, is just missing an x plus h on the bottom. So I'll do the same thing on the top. And in effect, I'm really just multiplying the 1 over x by 1. Okay, how about this middle term right here? That already has the x plus h on the bottom. It's just missing a factor of x on the bottom, so we'll do an x on the top too. Now the messy one is going to be this first fraction right here of h. That's missing both of these 2 factors on the bottom. So that'll be an x times x plus h on bottom, and the same thing on top. Sloppy notation here, guys. Sorry. So all of that is going to get multiplied together. All of that is going to get multiplied together. And all of that gets multiplied together, including this minus out in front. Whew, this is fun. All right, so equals limit as h approaches 0 of, oh boy, and here we go. This first one that I kind of bubbled here is just going to end up being, nothing cancels right there. So that's just going to end up being an hx times the quantity x plus h. Now the denominator of all that, I'm going to put on the bottom of the entire thing right here, which was x times x plus h. On to the second thing that I kind of did right here. When we multiply that 1 times the x, that's going to get us just plus an x on top. And again, that denominator was already listed right here, so we don't need to list it again. And then let's see, this x canceled out. Everything that's left over now, we're basically distributing a minus to that. That's going to end up being a minus x and a minus h all over that same denominator. Now, the only thing I haven't covered yet is this h right here. So if I wanted, I could do all of this again, but I'm hoping by this time you guys have done this enough to realize that, here we go, the denominator of the numerator, which I'm pointing to here and here and here, the denominator of the numerator and the numerator of the denominator end up in the exact same spot, and that would be the denominator of the whole complex fraction. So this factor of h is just going to show up as an h that I put down in my denominator. So I'll even kind of draw an arrow explaining where that came from there. Okay, so where are we then, guys? What I think I see right away, hopefully you do too, is that these x's in the numerator cancel out already. And now I think we actually don't need to do what I was about to do, but I have a feeling you guys would feel better if I did. I'm going to distribute this hx into that binomial right there. So this equals the limit as h approaches 0 of the hx times x is an hx squared plus the hx times h is going to be an h squared x. Those terms are gone, and then minus h at the end of all that. Over h, nope, sorry about that, over h, then an x times the quantity x plus h. Now, one of the things that should happen in all of these problems is that when you get done doing all of your algebraic trickery up in the numerator right there, all of the terms in the numerator that do not contain an h should have canceled out. And that happened here, guys. These x's right here canceled out, and way back before, where did we see that? It was, let's see, there was a minus x, and there we go. This x and this minus x, they canceled as well. The important thing then is that everything left in the numerator now contains a factor of h. So if you wanted to kind of show this step in a slick, sloppy way, that's fine, but I'm going to factor out the h, and that's going to leave me with an x squared plus, there's still one h there, hx minus 1 all over h, x, times x plus h. And finally now, this h in the numerator and this h in the denominator cancel each other out. And that was the problematic factor in the denominator that we needed to deal with. So we have a limit as h approaches 0. Sorry, my dog is very excited about the end of this limit problem right here. I actually don't need to write the limit because I'm ready now to evaluate this thing, substituting a 0 in for all the h's. So this now becomes, from right here, x squared plus that h becomes 0 times x, and then a minus 1. So let's do all of that. This term is just 0, and we end up with an x squared minus 1 for our derivative here, f prime of x. Okay, so all that work right there, and we are not done with this problem, guys. That is just our derivative, f prime of x. We need to evaluate all of this at a is equal to 4. Okay, so that's where we're at with this one right here. So we need to evaluate f prime of 4, which is going to get us a 4 squared. That's a 16 minus 1, which equals 15. And that right there is the slope of our tangent. All right, that's one of the things that we needed. They wanted that answer right there. We also need to evaluate the function f at 4 as well. Now, the function was, I thought I had this and I forgot it. Let me make sure I got it right. X plus 1 over x is really what we're dealing with right there, okay? So an x plus 1 over x, that would be a 4 plus 1 over 4. Nice and simple, guys. I'm just going to make that 4 and 1/4. And so putting that together, the ordered pair 4, 4 and 1/4, that right there is our point of tangency. So let's put all this together, guys. Starting in point slope form, I think I can fit this in the room I have left here. We're going to have y minus your y coordinate, 4 and 1/4, equals your slope, big, 15, and then times x minus 4. We'll distribute that 15 in there and get a y minus 4 and 1/4 is equal to a 15x minus 60. And then we'll add the 4 and the 1/4 to both sides here. And of course, it had to be a negative and a positive to make this real difficult. Y is going to equal 15x, and that's going to end up being minus 55 3/4. That is an ugly problem there, everybody, and I wonder if that isn't the way they intended it when they wrote it, but it kind of got away from them. That happens sometimes when you're writing hard problems like this, but that looks like our answer there to problem number 36.